good morning, guys. So in the last class, we discussed about FLSM, VLSM, and your OSI model. Also, we saw about TCP IP model. These models are the same thing, right? Just the name of the model is different, layers, they are the same. Clear? So any doubt with the FLSM, VLSM, or OSI model? No? Okay. So today we'll be discussing about TCP and UDP, and then we'll be going for the router components. So TCP and UDP, these are the two transport layer protocols. Okay. And these are responsible for communication, end-to-end communication. So we'll be discussing about these protocols. So if we discuss about your TCP stands for Transmission Control Protocol. Okay. And it is a transport layer protocol. Transport layer, layer 4. Okay. Layer 4 is the transport layer and is used on top of IP to ensure reliable communication of packet. Now, this term reliable transmission or reliable communication, this is important in case of TCP because only your TCP is the reliable protocol. UDP is unreliable protocol. Okay. We'll be seeing why TCP is reliable and why UDP is unreliable. Then your TCP include mechanisms to solve many problems that arise from packet-based messaging. Means there are certain problems that can arise in your communication. What are the problems? Such as lost packets. Maybe due to any reason. Okay, maybe there is a congestion in the network or there is a problem with the network or network reset. So some packets are lost. Or you can say out of order packets because maybe there is no sequence number. Then the packets can be arranged out of order. But in case of TCP, you see these problems has been solved. Means your TCP applies sequence number. If you remember yesterday on the segments, your TCP applies sequence number. With the help of sequence number, the receiving end is going to reassemble the packets in the correct order. Then duplicate packets because it is going to confirm that segment 1. If sender has sent segment 1, then the receiver is going to confirm that, okay, I have received segment 1. So means there is no chance of duplicate packets. Then corrupted packets. So if you remember checksum, with the help of checksum value, they are going to drop the corrupted packets and ask for retransmission.
Chance that sequence number is not added.
In case of UDP. In case of UDP, it will not be added. TCP, it will always be added. Yes.
You said out of order in the out of.
Yeah, out of order. So these are the problems that can arise in the communication. But your TCP has or includes mechanism to solve these problems. TCP overcome these problems by adding the sequence number. So in case of TCP, there will be no out of order packets. This is the thing. Clear? Then TCP protocol number is 6 because all the protocols that have been defined in the documents, they are having certain protocol numbers like your ICMP we'll be discussing. Okay. This is protocol number 1. Your TCP, it is protocol number 6. Means one by one, these protocols are having certain protocol numbers. Then the second protocol we have is UDP. Yes, please come. Yes. So UDP stands for User Datagram Protocol. Similar to TCP. Similar to TCP, this is also a transport layer protocol. Your UDP is also a transport layer protocol, but it is a lightweight data transfer protocol. Means this protocol carries, you can say like less overhead than your TCP. And we'll be discussing this thing about the overhead when we are discussing about the TCP and UDP header. We'll see that in your TCP header, there is a lot of information like your sequence number, your port numbers, okay, and acknowledgement numbers, all these things. But in case of UDP, will not be having anything like that. Then your UDP, it provides mechanism to detect corrupted data packets. Means your UDP, it also has the checksum. Okay. And by checking the checksum, it is going to drop the corrupted packets. But there is no such mechanism in UDP that it can ask for retransmission. Means your UDP, it is able to detect the corrupted packets and able to drop the packets, but not able to recover the packet or to ask for retransmission of the packets. Okay, so UDP provides mechanism to detect corrupted data packets, but it does not attempt to solve. See, does not attempt to solve other problems that arise with packets such as lost or out of order packets. So in case of your UDP, there can be out of order packets. Okay, let's say UDP. Okay, mainly UDP is used in the live streams. Okay, any live communication that is going on, UDP is working there. Okay, so let's say you're watching cricket match or you're watching news. So sometimes there will be a mismatch between the voice and video. Maybe the voice is coming first, the video is coming late. Why? Because that is based on UDP. And in UDP, there is no sequence number, no acknowledgement. So there can be out of order packets. It is a possibility. And this is the reason UDP sometimes known as the unreliable data protocol. Because you cannot rely on UDP. There can be out of order packet. There can be some packets lost. You're watching a live stream. due to any issue, let's say there is a connectivity issue. So some live stream has been lost, means you couldn't watch that. So that is not coming back. Okay. But in case of TCP, there is acknowledgement and they can ask for retransmission. There is an error recovery mechanism. Okay. If you have understood the error control part in yesterday's class, that what they are going to do, let's say packet number 1 received, segment 1 received, it is going to confirm. Segment 2 not received, segment 3 received. Then it is going to check that I have received 1, I have received 3, but I haven't received 2. So it is going to ask for retransmission of second segment. And the sender is going to send second segment. Once this is complete, it is going to arrange the data in the correct order, and then it is going to forward to the application. This is clear. UDP is simple but fast. Okay. UDP is simple but fast. Why fast? Because first thing, there is no acknowledgements. There is no acknowledgement in the UDP, means the sender had sent a segment. It is not going to wait for the acknowledgement. So if you make a request in case of UDP, so your server is going to just burden you with the data. It is based on request response mechanism. Means once you make the request, the server will start responding. Now it's not the problem of the server, or the server is not going to consider whether you're receiving or not receiving, the data is dropping or what. Okay. The news agencies who broadcast the live news, they don't care about who is receiving and who is not receiving. They'll just keep broadcasting. Okay. So your UDP, it is often used for time sensitive applications where time is more important than speed. Where time is more important than speed, UDP is used, such as real-time video streaming. All the real-time video streaming, that is based on the UDP, where speed is more important than accuracy. So always remember, when accuracy is important, there you will be using TCP, and where speed is more important, you will be using UDP. Okay. This is clear to everyone. Okay. The protocol number of your UDP is 17. Okay. Like TCP is 6, UDP is 17, ICMP is 1.
So it is in the sequence of what we discussed yesterday, like SSH having certain protocol number.
That is port number.
Port number.
Not the protocol number. There are two different things. One is the port number and one is the protocol number. So protocol number has been assigned in the order protocols have been defined, certain protocols. And these port numbers, they have been assigned to certain services. Okay, your SSH, your HTTP, HTTPS, these are basic services, or you can say protocols. Yes, please. So to deliver the data to the correct application, we use the port number. But to define a protocol, we use the protocol. This is clear? Okay. Now, first of all, about TCP. So before starting communication in TCP, before the communication takes place, there is a process that is going to check for the connection between the sender and receiver, source and destination. And that process is the three-way handshake. Until or unless this three-way handshake process completes, the communication is not going to start in case of your TCP. First of all, this three-way handshake will happen. Then only it is going to start the communication. Okay. So what is happening here? Understand. We are having a client and we are having a server. Clear? Now client wants to access or receive some data from the server. Client wants to receive some data from the server. So kind of, you can say your client is going to make a request to the server that I want to receive some data. Are you free? I want to receive some data. Are you free? Then your server is going to acknowledge this request. Okay. Your server is going to acknowledge this request that, okay, I'm free. I'm free. Then also your server is going to make a question that, are you ready to receive? Are you ready to receive the data? Then your client is going to confirm this request that, okay, I'm ready to receive the data. So both sides, they have confirmed that both are free and ready for communication. Means this particular state will be your connection established state. And once the connection is established, then only actual data transfer will start. Until or unless this process starts, data communication will not start. So first of all, your client, it is going to send a SYN segment. SYN segment is for synchronizing segment. This particular segment is used to synchronize. Okay, basically they are synchronizing the sequence number, that from which number we are going to start the communication. Like the first segment number would be 1, then second segment number would be 2, like this. Okay, so they are going to synchronize on a particular sequence number, and then the communication is going to start. So until or unless this three-way handshake process completes, they are not going to start the communication. Data flow will not start. Is it clear? Any doubt in this part, online people? So once the client sends that SYN segment, okay, the state will be active open because client has raised the request to synchronize the segments or synchronize the sequence numbers. Then your PC, your server, it is going to send two segments. One is the SYN and one is the ACK. Synchronize plus acknowledgement. Acknowledgement will be there for this particular SYN segment, and SYN segment will be there to ask the client for matching the sequence number. Okay, then client is going to acknowledge this request. Okay, so first segment will be the SYN segment, synchronized segment, and then your server is going to respond with the SYN and the ACK. There will be two segments. One will be for the acknowledgement and one will be for the sequence number. And then finally, your client is going to send an acknowledgement and they will form a connection, or this you can say a TCP session is established. They have established a TCP session. So before each and every communication, every time client wants to talk to server, your TCP is first going to perform this three-way handshake. If this three-way handshake is not there, data communication is not there. So this is why your TCP, it is known as connection-oriented protocol. Why connection-oriented? Because before the communication, it is checking for the connection. Okay. Without connection, it is not going to start the communication. So every time it is checking, that's why it is a connection-oriented protocol. And why it is slow? Because again, every time it is going to form, every time you want to communicate, it is going to have this three-way handshake. Clear? Now, once this three-way handshake has been completed, what is going to happen? Let's say again, same thing. This side we have client, this side we have server. Okay. Once this is complete, let's say your server sends segment 1, client side. Server sent the segment 1 to the client. Okay. And sequence number used, let's say 1 or 0 number. Sequence number used was 0. Now your client is going to acknowledge this request. For the acknowledgement, your client is going to say with the sequence number, it is always going to add +1, means sequence number +1. So this acknowledgement is going to have sequence number 1. And this sequence number 1, this particular acknowledgement is going to tell the server that now the client is ready to receive the segment number 1. Means the client is ready to receive the next segment. Then once server has seen this request, the segment number 1 in the sequence number 1 in the acknowledgement, it is going to send segment number 2 with sequence number 1. Okay. Now send again, it is going to add +1, and in the acknowledgement, it is going to say sequence number Y3. This was 1. Server has sent 1. So 1 + 1. Whatever sequence number is sent by the server, your client is going to add +1 in the acknowledgement. This +1, it is known as the ghost bit. Okay. And this particular sequence number in the acknowledgement, it tells the server which segment your client is willing to receive. Let's say acknowledgement for segment number 2. Now server has segment number 3. Server sent segment number 3 with sequence number 2. Clear? But this has been lost in the transmission. Okay. Then server sent the segment number 4. Segment number 2, then sequence number 3. So this has been lost in the transmission. Now what will happen? Your client will see that, okay, I had sent 2, correct? And then it is going to attach sequence number +1 means 3 + 1. So number is coming 4. So after 2 directly 4 means there is something missing. So your client, it is what it is going to do. It is going to send again that acknowledgement and sequence number 3. I want to receive the segment number 3. And then your server, it is going to retransmit the sequence number 3. So it is based on these sequence numbers. Okay. So by receiving the sequence number, server is going to know whether which particular segment your server client is going to receive. Is it clear? Online people?
Ajay, is it mandatory that sequence or segment is sending from 1 to?
No, they will be choosing a random port number. Random sequence number. This is why they are having this connection establishment, right? Because they both are going to agree on a same sequence number. Once they have agreed on the same sequence number, then they will start sending the packets with the particular sequence number. Is it clear?
Yes.
Okay. Any more doubts? No?
Range of sequence number.
Range of sequence number. It is a 32-bit, means 4 billion, 4.3 billion. Okay. Now, once the communication has been done, all the data transfer has complete in case of TCP. Again, to terminate the connection, they are having a 4-way handshake. To terminate the connection, they are having a 4-way handshake. Means, let's say this is again your client and this is your server. So once client has received all the data, your client is going to send a segment that is the fin segment, means finished segment. So client is going to tell your server that, okay, I have received the data, you can close the connection. Okay. So from client side, client has sent the fin segment. Then server is going to acknowledge this request that, okay, I'm closing my connection. Then server is also going to say that I'm done sending. You also close the connection. And then your client is going to acknowledge this request and the connection will be terminated. Okay. This is the half open or half active state, because one side connection is closed, but the connection from the second side was still open. And once both have sent the finished bit and acknowledged each other's finished bit, this connection will be terminated. After this, the communication will stop. So this is the four-way handshake. So to establish the connection, there is a three-way handshake. And to close the connection, it is four-way handshake in case of TCP. But in UDP, we don't have any procedure like this. And this is one of the other reasons your UDP is fast, because it is not checking for the connection, not doing anything to terminate the connection. Okay, request and response. Once you make the request, server is going to send all the data and stop the communication. That's it. Clear? No, there is no such mechanism to ask for acknowledgement in case of UDP. Okay, we'll be seeing when we are checking on the headers. This is the UDP packet flow. Yes. Huh?
Examples for this.
TCP, most of the communication is for happening through the TCP only. Like, let's say whatever files we are downloading through the internet. So we get the files proper. Why? Because it is happening on TCP.
It is
Okay.
accuracy, right?
Yes, because TCP is accuracy. TCP is mainly focusing on the accuracy. Or we can say, simple example, I'll give you the WhatsApp. We are getting the acknowledgement. The message has been sent. The message has been delivered to the receiver. Message has been read by the receiver.
What's a video call will be UDP.
Yeah, video call will be UDP. Because due to network issue, if some video has lost, that is not coming back. So all, yes. So all the live streams, anything going live, that is your UDP. And if we are having confirmations, if we are having acknowledgements, that is your TCP. Clear?
So earlier we discussed about OSI model where like each layer are adding value
Yes.
to like checksum and all that thing. And this particular thing of port means transport layer is something which is mechanism happening in the server level, server and client level.
Yeah, end-to-end communication.
Inbuilt in
That's
server.
why it is known as the heart of OSI, right? Because end-to-end communication is going to start at this particular layer. Yes, please.
If you're watching a movie online, would that be UDP? Because that's not real time.
No, that's not UDP.
That's TCP.
Yes, because it has been already stored in some server.
Okay.
It's not going live. We are just streaming the movie from the server because we can stop anytime. We can rewatch it. We can rewind it. So it is TCP. If it is going live, like your news channels, okay, or some kind of live show, that is your UDP.
What if it's like a video? Is that UDP?
Like if you are talking about like,
Online.
yeah, online gaming, esports, that is on UDP. Because if you are having a network glitch, that doesn't mean your game is going to stop. Okay. Is it clear?
Yes.
Now, if we check the UDP packet flow, see, there's no mechanism. Direct, there is a sender, there is a receiver. So if the receiver makes a request, the sender is going to just respond, nothing else. That's it. Server is going to send all the data and stop the communication. It is not going to care about whether the receiver is receiving or not receiving, whether the receiver is available or not available. Okay. They are not going to care for anything. It is basically working on request and response. And this is why it is fast, because once you get the request, it is going to directly respond without checking anything. Clear? Then these are some differences between your TCP and UDP. So first of all, your TCP is connected or connection oriented, you can say. Okay, it is going to check for the connection. Connectionless UDP, not going to check for connection. Why? In TCP, we have three-way handshake, and without three-way handshake, we will not be having communication. In case of UDP, there's no three-way handshake, means no checking for connection. So it is connectionless. Then your TCP, it is going to check for the connection state also, whether it is connected throughout the session. Okay. And UDP is stateless because no, it is not going to check for the connection. In TCP, at any point of time, if the communication breaks, if the TCP session breaks, then the communication will stop. You will have to restart the communication. Okay. Yes. Okay. Then in TCP, byte stream, or you can say segment. The word segment is used in the case of TCP. In case of UDP, the datagram word is used. At transport layer, we say segment. In case of TCP, when we are using the UDP, it is datagram. Okay. Then in case of TCP, there is ordered data delivery. Means they are going to reorder the data in the correct sequence. Then only the data will be delivered to the correct application. But in case of UDP, there is no sequence guarantee. Okay. TCP is reliable. UDP is lossy. In UDP, packets can be lost, but in case of TCP, packets can be recovered. If a packet is lost, that can be recovered. Then your TCP is error-free because it checks for error. It has mechanism to recover from errors. But in case of UDP, the error packets are discarded, but there is no mechanism to retain them or recover them. In case of TCP, we are having 3-way handshake and 4-way handshake, and there is no handshake. In case of TCP, we have the flow control, increasing or decreasing the speed of communication according to the receiver needs. But in case of UDP, there is no flow control. In case of TCP, TCP is relatively slow. Why? Because it is having certain procedures like 3-way handshake, 4-way handshake, acknowledgements. But in UDP, there is no such procedure, means it is relatively fast. Your TCP, it is used in the point-to-point connection, mainly used for point-to-point connection. And your UDP, it is mainly for multicast, when you are providing data from one to many, like your live streams and all. Is it clear? And in case of TCP, when we are communicating, we are generally talking one-to-one. This is clear?
So you mean to say that we use the UDP for broadcast streams?
Yeah, all the live stream or live video streaming means where speed is important than accuracy, you are going with the UDP. And when accuracy is more important, you are going with the TCP. And when I'm saying we use, means we do not decide. Okay, these are the certain protocols, because ultimately TCP and UDP is what? Protocols only. Okay, so your TCP and UDP or your transport layer, it provides service to your application layer protocols. Means like your HTTP, HTTPS, they work on the TCP. They work on the TCP. So TCP is just providing service to them. Whether their communication will be proper, it will be like reliable or unreliable. Okay. So your transport layer, this TCP and UDP, they provide service to the application layer protocols. Okay. Like when I say HTTP uses port number 80. So uses port number 80 with the TCP protocol. Okay. HTTPS, port number 443, again TCP. SSH, port number 22, again TCP. DNS, port number 53, uses TCP as well as UDP. Both. In some cases, TCP, and in some cases, UDP, depending on the need. Okay. Then certain protocols like SMTP, port number 25, TCP. So most of the communication, it is based on the TCP only. There are certain protocols we use UDP. There are certain protocols that are going to use UDP. Is it clear? Yes, please.
So suppose we are like logging into any of the live stream websites. So that includes HTTPS.
Yes.
So then it will be TCP.
Your HTTPS communication, that is TCP.
Okay.
But the video that is coming through the UDP.
Okay. So you mean to say?
Yeah, I'm not saying in one communication there will be only one protocol. No, there will be more than one protocol. Like even your HTTPS. Okay, so how it is secure? The security is being provided by the TLS or SSL. So only it is not like this that at one point of time only one protocol will be working. For a proper communication, for a better communication, more than one protocol. Certain lot of protocols will be working together to provide you the best experience. Is it clear? Yes, port number 53, DNS. Clear? Any more doubts? No? So now we'll be seeing the headers, TCP header and UDP header. So first of all, this is your TCP header. Okay. Means what is a header? If you remember, with the data, let's say this is your hi message. So with the data, if you attach any information in front of the data, extra information, that is your header. And in case of TCP, this is the header that is attached. This much information is being attached. So this particular information is what? We have the source port number, means from which application the data is originating. Destination port number, for which application the data is destined. Both the source port and destination port numbers, they are of 16 bits. And 2 raised to power 16 is 65,536. Means these port numbers, they range from 0 till 65,535. These are the port numbers when we are discussing about HTTP, HTTPS. So these are the port numbers. Okay. So that number of ports is same, whether it is source or destination. So they are both are 16 bits, means both can range from 0 till 65,535. Okay. So let's say that my system, I have a system and I want to access a web server, google.com. So Google is HTTPS. So means my traffic is going for HTTPS service, means my destination port number is supposed to be 443. And for communication, my system is going to generate a random port number, let's say 64,001. So this will be the values like this. So for communication, the system, the source is going to generate a random port number, but the destination application will always be fixed. The destination application will always be fixed, depending on what type of protocol or what type of protocol you are using. Then we have the sequence number. This is the sequence number. So total 32-bit. If you see 16 plus 16, total 32-bit. So your sequence number is a 32-bit number. Can range from up to 2 raised to power 32. So 0 till 4.3 billion something. This is clear. So they, with the help of this TC sequence number, your server and client are going to communicate. Let's say the sender is going to send with the sequence number. So in the acknowledgement number, for example, let's say sequence number was sent 1 by the sender. So when the receiver is sending the acknowledgement, first of all, it is going to say that this is for sequence number 1 and acknowledgement number will be 1 plus 1. Ghost bit added. That will be 2. When the receiver is replying, if the receiver is replying, I have sent sequence number 1. So receiver is going to say, okay, now I am ready to receive number 2. Then it is going to send number 2. Then it is going to say, I'm ready to receive number 3. This is how they are going to communicate with the help of sequence number and acknowledgement number. This is clear. Then we are having header length. So what is header length? Header length is basically going to tell your send or receiver that in a particular segment, this is total segment. In this particular segment, what is the size of the header? So when receiver is going to know about the size of the header, it is going to know, okay, from where the actual data will start. This is how it is going to identify the data. Looking at the header length. How many bits? 4 bits. 2 raised to power 4, 16. Clear? Okay. Then we have some reserved bits. And these reserved bits, they are never used. They are always 0. These are not used for any purpose. Okay. Then we have an urgent bit. When this urgent bit is, these are the TCP flags actually. Okay. These are known as the TCP flags. So these TCP flags, the first flag is the urgent. So whenever this urgent flag is set to 1, always remember the values of these flags either 0 or 1 binary. So if this is set to 1, means the receiver is going to understand that this particular segment is needing some extra attention, some extra care it should be given. So during, let's say, if you want to send some important data, then you can set this urgent bit to 1. Okay. Then we have the acknowledgement. So whenever the receiver is sending acknowledgement, it is going to set this bit to 1. This acknowledgement flag to 1. Then we have the push. So what is the push flag? Let's say you are sending some data. Okay. And the data that should be directly given to the application. So you can say the push bit on. So whenever the push flag is on, your receiver on each and every side, always remember, again, sender and receiver. So on each and every side on the NIC cards, they are having certain memory. That memory is known as the buffer. Okay. So before sending data to the application, the data is, or the segments are stored in the buffer. Why? Because if they will store in the buffer, then they are going to check for the sequence number, then they are going to reorder them and then send to the application. So they need to store the data so that they can rearrange it. Okay. So when this push flag is on, it is not going to wait for the entire buffer to fill. Your receiver is not going to wait for the entire buffer to fill. It is going to instantly push the data to the application in case of push flag on. Then next we have reset. Let's say communication is happening and we are having corrupted packets. We are having corrupted data packets. So this reset flag can be set to 1. And once this reset flag set to 1, means your communication will restart. The connection will be established again. Connection will be instantly terminated and it will be re-established. Then we have the SYN segment. If you remember, first three-way handshake, the first segment is the SYN segment. In that particular SYN segment, this SYN bit is going to set to 1. Then we have the FIN, if you want to finish the communication. So these are the flags. Then we have something called as window size. What is this window size? This window size is going to tell your sender, let's say I'm the receiver. Again, we have one sending system and one receiving system. So this window size basically helps in your flow control. Okay, how does it help? This is the sender, this is the receiver. Sender is sending the data. So the receiver in each and every segment, in each and every acknowledgement, your receiver is going to tell the sender that I can receive, let's say in this it says 1200. So means your sender will understand the receiver is willing to receive 1200 bytes without any drop. Okay, so it is going to send the 1200 bytes. Now let's say it is next time the buffer is only 600 bytes free. So it is in the window, it is going to say I am willing to receive 600 bytes. So your sender is going to send 600 bytes. And this is how, if you understand, let's say you are downloading some file from the internet. So your speed that keeps on varying. You don't always have the same speed. Depending on the connection, your speed varies. And still you get the complete file. Still we get the complete file because we have this window size. So with the window size, your receiving application, your receiving side transport layer, it is going to inform the sending side that how much data it is willing to receive without any drop. And your server or the sending side is going to provide only that much of information. Is it clear? Then we have the checksum. Okay. So what is the checksum? Again, your TCP or your transport layer is going to run some algorithm on the data. It is going to check, calculate a random value, and that particular random value, let's say 1, 2, 3, it is going to store in this checksum. Now, once the receiver has received, receiver is not going to check this information. Receiver is going to first calculate or run the same algorithm on the data. Once the same algorithm has been run, receiver has calculated its own value, then it is going to compare with these two values. If they are the same, data has not changed, data is not corrupted. And if they have changed, let's say 1 to 4, that means data has been changed in the transit and the packet is going to be dropped. Clear? Then we have the urgent pointer. What is this urgent pointer? When this urgent bit is set to 1, the data needs to be given special care, right? So how much data needs to be given special care? That will be defined with your urgent pointer. Is that clear? Then these are some optional bits. Okay, these are some optional bit, and after these optional bit, we are having data, your actual data. Clear? So your TCP header, it is ranging from 20 bytes to 60 bytes. It is ranging from 20 bytes to 60 bytes. So by default, if you are not using any options, it will be 20 bytes. And if you are using options, so you can use 40 bytes of optional information. So it will be 60 bytes. This is clear. TCP header clear? Any doubt? Yes, please.
When you asked about told about the reset.
Yes.
So, say for example, the first of all, the reset would do what it will do. It will reset the communication.
Yes, it is instantly stop the communication and reinitiate the
Say
connection.
for example, we are in the middle of the data transfer.
Mhm.
So in the middle of that, if that reset got activated, then all the connection would be reset.
Mhm.
And whatever the data which had been copied till that time,
Mhm.
that might.
Okay, no problem. See, session layer. Establish a session, maintain the session as long as the communication or data transfer completes. And once the data transfer complete, then only it terminates the connection session. Correct? Okay. Along with that, it has one more task. It adds checkpoints. It adds checkpoints on the data. Let's say you are transmitting 100 MBs of information. Okay. So let's say your sending side is attaching a checkpoint at every 5 MB. Now your data transfer has been completed 52 MB and somehow your connection dropped. This is what the question is. Okay. Now your receiving side is also acknowledging these checkpoints. So your sending side is going to check, okay, 50 MB checkpoint was passed, but 55 MB checkpoint was not passed. Means I can start from 50 MB. Correct? So next time when you start the communication, it is going to start from the point it stopped. This is clear? Not from the starting. In some cases, when these checkpoints are not available, then like in some downloads, you might have noticed that they start from the place they stop. And some downloads, they do not start from the place they stop. Okay, so all this is the checkpoints. Clear? Any more doubts?
Sometimes it's happened in WhatsApp also.
Like
If video, if it is downloaded half,
Mhm.
again, if I reinitiate, then it starts from 0.
Yes, happens. If it is not downloaded correctly or the packets are corrupted. Okay, this is clear. Online people, any doubt?
No.
Yes. Options. These are, see, if I show you the TCP header, there are a lot of options. In this you will not see. Show. This is the header length. Finish bit, window size, checksum. These are the options. See, there are certain options like timestamp, window size extension if you want to increase the window size. Okay. Then parameter negotiation or padding. These are certain options. Timestamps, when wrap around the time is less than the lifetime of a segment. Means the life of a segment is less, I mean greater than the wrap around. Okay. So these are certain options. Clear? You can read about them. I will share this link. Okay. Then if you compare, TCP header is having a lot of information, correct? But if you see the UDP header, much more simple. not very much of information. Okay, only source port number 0 till 65,535 only. Okay, that is only 2 bytes. Means 2 bytes means, okay, one more thing you need to understand, there is a bit, there is a byte. Okay, so 1 byte is having 8 bits. 1 byte is 8 bits. So this is again total 16 bits only. Okay, means 0 till 65,535. Same thing, destination port number 2 bytes. Length, header length, that is 2 bytes, means 16 bits. And it has the checksum to check for the errors. But there is no, if you see, is there any acknowledgement? No, right? There is no acknowledgement. And there are no flags also. So your UDP, it cannot recover from the errors. And there is no window size option. So it cannot like increase or decrease the size of or speed of communication. No flow control means. Okay. So it can check for errors. It can drop corrupted packets, but it cannot ask for retransmission. There is no such information in the header. Is it clear? So TCP header and UDP header is clear. Any doubts? No? Okay. Next, we'll be discussing about your router. Okay. We are starting with the router. So router is a layer 3 device, correct?
Yeah.
And provide communication between 2 different networks. Okay. So this is the information we have already seen when we were discussing about network components, that it is a layer 3 device. It is an intelligent device, means it is going to store information that which network, like to a particular network, how it is going to reach that with the help of routing table. Then your router has per port collision domain, means your router is not going to forward broadcast traffic from one port to another port. Then it has per port collision domain, and it is a full duplex device. Okay, means it can have two-way communication at the same time. Then your router uses IP addresses to communicate. IP address is a layer 3 information. Yes, please.
So, sir, for a switch, when the data is running through the switch, it stores it in the CAN table, right?
Yes, CAN
But
table.
for routing, it's not
Routing
CAN
table.
table. What is it called?
Routing table.
Say that.
Routing table.
Routing TV,
Routing table.
routing table. Okay. And like, let's say the data runs through the router like one time. Does it stay there forever, or like, does it restart?
The routing table, it
Yeah.
stay there.
It'll stay there.
Okay, as long as the protocols are running,
Mm.
so it will stay there.
And same for switch too.
In the same in the switch, the CAM table, it keeps on refreshing.
Oh, just refresh.
Yes.
So it will go.
If you like, if a particular communication it is not being used for a long time,
Ah.
so it is going to refresh.
Has a refresh time.
Is it clear?
Also, can you explain the fourth point, per port collision domain?
Per port collision domain. So if you understand the collision domain is what? A network or part of network where there is a possibility of collision. So when we are saying per port collision domain, means for each and every port, there is a separate collision domain. Means when one port is communicating with the other port, there is only these 2 ports communicating. These 2 ports communicating with each other. And it is a full duplex device. So they can have the simultaneous communication. This is why it is known as per port collision domain. Is it clear?
Yeah, it's clear.
Okay. After this, we have components of the router. So router, it is having certain components like your ROM, RAM, NVRAM, flash, bootstrap, and host. So what is ROM? Read-only memory. Means basically it is what? A memory going to store some information. So what information your ROM in the router is going to store? It is going to store the bootstrap program, or you can say bootloader. Okay, your ROM, it is only programmable once. Means you can only write data once in a ROM. After that, data cannot be written in the ROM. Okay, after that you can read the data, but you cannot write the data. Like you can say BIOS of your computer. Okay, your BIOS, it is manufactured by the manufacturer, the vendor who has created the motherboard. Clear? And do we change the BIOS all the time? No. Why? We cannot change it. Why? Because it has been installed in the ROM. So even your Windows corrupts, your BIOS doesn't corrupt. But your BIOS helps you to start your system, to install Windows and to use your system. Why? Because it is in the ROM. And in ROM, even by mistake, it will not be deleted or modified. Yeah, that is a different thing, that your ROM itself goes off. Okay, due to any electrical failure or something like that. But by default, your ROM, it is only read-only memory, means you can read the data, you cannot write the data. And in case of router, it is going to store the bootstrap program or bootloader. Then second, we have RAM. RAM is random access memory. Okay. So first thing, your RAM is volatile in nature. Means your RAM is going to store information as long as there is a power. When there is no power, there is no information in the RAM. Your RAM will get flushed. Okay. So it is going to temporarily store the information. It is going to temporarily store the information. So what your RAM stores, it stores the running configuration, means whatever the configuration is running in the router. Okay. Whatever configuration is running in the router, that particular information or that particular configuration is going to be stored in the RAM. But there is a problem, because when we turn off the router and switch it on again, the information is going to lose. Correct? Because it is volatile in nature. It cannot store information without power. Okay. So for that purpose, we are having NVRAM. NVRAM means non-volatile RAM. So this RAM, NVRAM, it is non-volatile in nature. Means it is going to store the information even if there is no power. Okay. So your running configuration means the configuration running in the router, that is stored in the RAM, and the backup of this configuration. Okay. The backup of this running configuration is stored in the NVRAM. Okay. And that configuration is known as startup configuration. Why? Because when you switch on the router again, RAM is going to be empty. There will be no data in the RAM. So your router is going to check in the NVRAM whether there is some kind of configuration present or not. If the configuration is present, then it is going to load in the running configuration or RAM, so that your router can function. Because for a router to function, it will always be functioning on the RAM only. It will always be functioning on the RAM. So we need the configuration in the RAM for the router to function. But to keep backup, so that when we power off the router and power it on again, we will need a backup in the NVRAM. So this backup will not be automatically created. We have to create the backup by executing some commands. Clear? Then we have the flash memory. This flash memory is going to contain the operating system of your router. Okay. iOS, we call it as. Okay. The operating system of your router switches, we call him iOS, Inter-Networking Operating System. Inter-Networking Operating System. Then this bootstrap, it is a program of the router stored in the ROM. So this bootstrap program is going to help you boot your router, start your router. So whenever your router starts, this is the first program loaded, the bootstrap program. And this bootstrap program, it is only going to load the flash, I mean the iOS from the flash, and going to copy the startup configuration into the running configuration. Clear? It is going to load the operating system. Then the operating system is going to check in the NVRAM whether there is a configuration or not. If there is a configuration, it is going to load in the running configuration. And there we have one more component, that is the post, power on self-test. This is available in all your devices, even your computers, laptops, and all. What is power on self-test? That it is going to check your hardware configuration. Let's say you are starting a computer. So if all the parts are working properly, then your computer is going to start. If there's a problem with the RAM or hard disk or anything, it is going to stop the booting. It is going to provide you an error. So this is the feature of post. Clear? This post program is also stored in the ROM. Any doubts in the components? No? Online people?
So if you don't mind, can you please give me the example of NVRAM?
NVRAM, it is just a memory. What example I should give? It is just a memory.
Call us WhatsApp.
No. In WhatsApp, I cannot give this example because there's nothing related. Okay. Memory is simple, like your RAM is also memory, right? So your RAM is a physical device. Same like that, your NVRAM is also physical device or a chip attached in your router motherboard. Okay.
So flash is a separate component like RAM.
Yes. In some routers, you will see the flash outside. It is a small chip. Let me show you also. See how
So when you buy a new router, so the flash will come along with that?
Yes.
Or...
Depending on the series. It is a small chip like this. Okay. You are going to just install it in the router. Clear? And where you are going to install it, you can check in the packet tracer.
So when you upgrade the router version, you are doing it on the version is getting done in flash?
Yeah, because the iOS is in the flash. So your router is having certain slots. In these slots, you attach the flash memory. Okay. Then we have the flow chart of the router. Means what is the process that happens when your router, you power on the router. So see, once you power on the router, the first process happens is the post, power on self-test. Your router is going to check all the hardware components, whether all are working properly or not. Once your post check has passed, it is going to load the bootstrap program, means your bootloader. And your bootloader, it is going to check for the IOs in the flash memory. Okay, so IOs can be present in the flash memory in the TFTP, and if nowhere available, we will be using the Roman mode to restore the IOs in the flash. Okay, so once the IOs has been found, it will be loaded into the, your IOs will be loaded. Then your IOS is going to check your NVRAM, whether some configuration is present in there or not. If the configuration is present, then it is going to load the configuration to the RAM. If not present, it is going to just start the router without any configuration. This is clear. This is the process. So flash memory stores the IOs. If there it is not there in the flash memory, we are going to use the TFTP server to load the IOs. Okay. So if using the TFTP server, understand, if there is no IOs in the flash memory, we will directly jump into the Roman mode. Okay. In the Roman mode, we are going to use the TFTP server to load the IOs back to flash memory. Once IOs is there in the flash memory, IOs can be loaded.
It means we need to connect with the internet source for TFTP server.
No. We can, a local system also, we can create a virtual TFTP server.
Local system is which is residing in that.
Like my laptop. Let's say I'm having a router in company. So I can use my laptop to create a TFTP server. But in enterprise levels, they will be having a separate server only. Companies are already having servers. So in that particular server, you create TFTP application. You use a TFTP application and create a TFTP server. Okay. And then you just take the backup. Because if you remember, FTP and TFTP, these are the two protocols. I have discussed them in the, I think, network components only. I have discussed. So these are the two protocols. When I said we'll be using them for the IOS backup and restore, or not discussed in your class, I don't know. Not discussed. Okay, just understand these are the two protocols. Okay, we have discussed them. I can show you yesterday itself. Application layer protocol, FTP, right? HTTP, HTTPS, FTP, SMTP, SSH telnet. Okay, let me show you. I think you guys forgot. Right? Yesterday discussed, right? Yes. Okay, no problem. Still understand again. FTP, TFTP. These are the two protocols, and mainly we'll be using the TFTP. Why? For certain purpose. We'll take backup of IOS. We'll take backup of your configurations. Because for enterprise levels, the configurations are really important. Okay. Then while restore also, we are going to use the TFTP server, because we'll be taking backup in the TFTP server and restoring from the TFTP server itself. Okay. So I'll be showing you this all with the practical also, that how you are going to take backup and how you are going to take restore the IOS and all.
Just a doubt.
Yes,
so in live production and in corporate also, we are using this TFTP for backup and
yes, you have the choice. You can use the TFTP or FTP. Okay, but TFTP is the easier one, because in TFTP you don't need username and password to do the backup and restore. But your FTP, it is a secure protocol. Okay, so in this you are going to authorize yourself, authenticate yourself before taking the backup and restore. Is it clear? So we are having the practical for TFTP. I'll be showing you how to take backup and restore of configurations as well as the IOS. So this flowchart is clear. Okay.
So this is for emergency case only.
Yeah, emergency case only. Backup you will be taking always. Backup you will be taking always, but restore in case there is an emergency. Let's say due to any reason your router is damaged. So when the router is already okay, or in the some other router also, you can take the backup of the configurations. I mean, restore the configuration and use the. Okay.
When it comes to restoring, can we restore it for the upgraded version of the router?
No, that we cannot do. Why? Because there can be certain changes in the port numbers. Like, let's say there is a 2911 series. Okay. In that, interface are like Z0 by 0, Z0 by 1 interface name. But if you go for the 4331, you'll be seeing Z0 by 0 by 0. Interface changed. So that configuration is not going to be loaded here. Okay. Yeah. Either you do the manual configuration or you use the same series of router. Okay. So if you use the same series, then there is no issue. That will directly going to work. Then we are having certain modes in the router. So once you start the router, let's say this is your router. So now onwards, we'll be using this packet tracer application. Okay. So you guys have to download this application from the Networking Academy, Cisco Networking Academy website and install it. Okay. Then we'll be using this software for all our practicals. Okay. See, this is the router. Whatever router I have taken, like I have taken 2911 series. Okay. This is the physical view of my router. if you see here, there are certain slots. These slots are known as expansion slots. Okay. In these slots, you add some expansion cards. And why you add these expansion cards? Let's say you want more number of ports in the router, or maybe you want some different type of port to connect the router to the firewall or fiber technology or anything. So you can add that particular card and start using. Then we have the auxiliary port here. Okay, this is used to connect the router to modem if you want to access the router in WAN. We have the console port. If you remember the console cable. Okay, so you connect the one part of cable here and the other part in your system, and you take the local access for initial configuration of the router. Because for accessing in WAN, you will be needing an IP address, right? So for initial configuration, we'll be using the console port with the help of console cable, and we'll do the initial configuration. Then these 3 ports, 1, 2, and 3. These are the Ethernet ports. Means you can say you can connect 3 switches, and you can design 3 networks with the help of this router. Okay, and then there are 2 USB ports. Okay, then there is a power button in the router. Right now, you can check the status. Light is green means it is on, and if I turn off, it's off. Clear? Now, once you power on the router, if you go to the CLI, let me just take another router. So you can see fresh. So I'm taking the router. Turn off, turn on again. Now you see. Screen is black. Screen is black. Not support.
So during packet tracer, always you have to turn on the router like this.
This is strange. If I'm showing you the router, it is saying, okay. Okay, full screen is not working. No problem.
So I have a doubt. So while using packet tracer, always we have to switch on the router.
Yes.
So if you are making a network diagram of a couple of routers and switch, so all the devices needs to be turned on.
Yes, all the devices needs to be turned on. Then only they will be functioning right. Okay, no problem. It is not supporting. So you see, initially, what is getting loaded? Bootstrap program. After the bootstrap program, your flash will be loaded. Okay, in your IOS will be loaded. So they see there will be IOS is load test, and once IOS is found, they are going to self-decompress the IOS image. And once the IOS has been loaded, it is going to load your NVRAM content into the RAM, and your router will turn on. Okay. So once your router turns on, for initial configuration, when there is no configuration in the router, you are going to see this system configuration dialog. When there is no configuration in your router, you are going to see this system configuration dialog. And this system configuration dialog, this is going to help you for the initial configuration. Okay. Now you get 2 choices. Would you like to enter the initial configuration dialog? You can say yes, you can say no. Once we are familiar with the commands, we are always going to say no. Why? Because when you go with this system configuration dialog, it is going to ask you a lot of questions. Okay. See, let's say I'm saying yes. So first question it is going to ask, would you like to enter basic management setup? Okay. Let's say yes. It is going to ask for host name of the router. Okay. I'll say R1. Now it is going to ask me for enable secret. Now what is the secret? So it is going to tell you also what is this thing. So enable secret is a password used to protect access to privilege access and configuration modes. So again, let's say we have to set some kind of password. I'm setting 123. Then it is going to ask for password. So what is password? In case you haven't set the secret, it is you have to enter the password. So let's say I'm saying 456. Again, one more password. Okay. 789. Configure SNMP network management. Again, we do not know what is SNMP. So it is going to ask a lot of questions like this. And we do not want all this configuration right now. So what we are going to do, we are always going to say initially no. Turn off the router, turn on again. Loading the IOS.
It is related to iOS, right?
Yes, iOS.
What about the Windows?
About the Windows mean?
I mean, like iOS only for the MacBook.
No. That is different iOS.
Okay.
See, there are certain terms. One is the ISO. Second is the iOS. Third is the iOS. And fourth is there's one more term. ISO. Okay, OSI. These are 4 different terms. ISO, it is the International Organization of Standardization. IOS, Cisco Internetworking Operating System, router and switch operating system. This is what you talk about the Apple. And OSI, it is the model. Okay. So when I'm saying IOS, this is we are talking about router and this IOS. And this is different for the Apple. Is it clear?
Yes.
Okay.
So there is a story behind that. So the Apple's I is small here because Cisco has taken the trademark before for iOS.
Yeah.
So that is why Apple uses small I.
Got it?
Okay.
So in the initial system configuration dialog, we are going to say no. Once you say no and hit enter, you are going to see a prompt. From here, you can start executing the commands. So this is the first prompt. So this first prompt, it is your user execution mode. This is known as user execution mode. In this mode, you can run very limited number of commands, very limited set of commands you can run in this mode. And usually you are not even going to use this mode. Okay. You will use this mode just to jump into the privilege mode, second mode. How do you identify the user execution mode? You will see the host name of the router and you'll see a greater than symbol. This is the prompt for your user execution mode. So if you see this greater than symbol, that means it is always user execution mode. Is it clear? If you want to know what are the commands you can execute in this mode, you can just give a question mark. Okay. So if I give a question mark here, these are the commands I can run. Clear? These are certain commands. If you want to connect to it, open a terminal connection, if you want to turn off privilege commands, disconnect, or if I want to turn on the privilege commands. So these are certain commands. I can use the ping command to test the connectivity also. Okay. Now see, this mode I'll always be using just to go to the privilege mode. Mean to turn on the privilege commands, all these same commands, all the user execution mode commands you are going to find in the privilege mode also. Same commands. But extra commands will also be there, more commands. Why? Because they will be the privileged commands, the commands with the high privilege. So to turn on them, you have to give the command enable. Okay. So I'll say enable and hit enter. You see the prompt has been changed. Now from the greater than symbol, it became hash. And this is our second mode. So first mode, user execution mode. And you are going to identify with the help of router greater than symbol. If you give enable command in the user execution mode, you will land into the privilege mode. Second mode is the privilege mode. And you're going to identify it with the help of router hash. So if you see the hash means it is the privilege mode. Now, if you check the number of commands in the privilege mode, if I give question mark, these are more than the commands in the user execution mode. And all the same commands are there. You see, connect, disable, disconnect, enable. Okay. Also the ping command, resume command, all commands are here. But there are some extra commands also. So why do we use this privilege mode is if you want to monitor or troubleshoot the configuration of your router. Let's say you have done some configuration, but there is a problem. So if you want to check whether the configuration is correct or not, if you want to verify, then you are going to use the privileged mode for all the monitoring and troubleshooting purpose. This is clear?
Yeah, basically, the privilege mode is kind of an admin.
Yeah, you can see, but still you can do a very limited number of configuration in the privilege mode because entire configuration of the router will be done in a third mode. Okay, that is your global configuration mode. Okay.
So it doesn't mean any kind of security while logging.
No, security and everything that will be added in the global configuration mode. Okay, all the configuration commands, they will be run in the global configuration mode. So to go into the global configuration mode, your command is configure terminal. We are going to make configurations. If I hit enter, you see my prompt has been changed. Okay, so this is your global configuration mode. In this mode, you are going to do the entire configuration of your router. Global configuration mode. And identification, you'll be having config and hash. Okay.
We can set out a password for this.
Password on?
I mean, the global configuration.
No, you cannot set password on global configuration mode. You can set for the privileged mode. But the commands to set the password, they will be executed in your global configuration. Like you say, enable secret, enable password. Those commands you will run in the global configuration mode, but the effect will be there on the privileged mode. You will be asked for password before going into the release mode. So we will be discussing those commands also. Okay. So this is our third mode. And in this mode, we are going to do the entire configuration of the router. Means all the configuration you want to set password, or you want to turn on the telnet SSH access, or you want to do the routing and all. So all the tasks that will be done in our global configuration mode. Okay, let's wait. Power issue, so we'll wait for some time. Okay, Wi-Fi is also gone. Okay, so the global configuration mode, it is our third mode, and in this mode, we are doing the entire configuration of the routers. Now your router, it is having certain interfaces. We have seen like 3 interfaces we saw about Ethernet. Okay, so if you want to set IP address on those interfaces, you have to go to the interface configuration mode. So if you want to go to the interface configuration mode, how you can go? You have to be in the global configuration mode, and in the global configuration mode, you have to execute a command. What is the command? First of all, you must know about the interfaces. What are the interfaces available in your router? So if you want to know about the interfaces available on your router, you can just check out the router. You can have the physical view of the router, and it is going to provide you the numbers. Okay, let's say this is 0 by 0, this is 0 by 1, and this is 0 by 2. Visible? Okay. So if I tell you about this, this first interface, it is your ZE 0 bar 0, ZE 0 by 1, and this is ZE 0 by 2. Means gigabit Ethernet. This is a gigabit technology, means 1 Gbps of connection is there. Okay. See, there is a Ethernet, there is a fast Ethernet, there is a gigabit Ethernet. Your Ethernet technology, it is having 10 Mbps of bandwidth. Fast Ethernet is having 100 Mbps, and your gigabit Ethernet is having 1 Gbps. Okay, so means this router is having connection of 1 Gbps. Okay, so these are the name of the interfaces. So according to the interface, in which interface you are connecting the cable to the switch, that particular interface you are going to provide the IP. Let's say I'm going to use ZE 0 by 0, gigabit Ethernet 0 by 0. So what command I'm going to execute? So I'll go to the global configuration mode again. In the global configuration mode, I'll say interface and the name you saw on the interface, ZE 0 by 0. Okay, whatever name was there on the interface, you write the same name. Hit enter. Take it Z. Okay, this is clear. Why it is not taking ZE? Because according to router, the name is, sorry, gigabit Ethernet. Okay, and I wrote ZE, so this is not matching. ZI should be there. If I show you the complete command, it is something like, let me say exit. So the command is interface gigabit Ethernet 0 by 0. Okay, so if I abbreviate it, if I make it the short form, so it should be ZI, not ZE. Okay, so you can also go in the short, like for interface, you can say INT, and for gigabit Ethernet, you can either say ZI or simple Z also, and the number of the interface. That's it. Okay, then in this particular mode, if you see the configuration mode here, config if. So this is your interface configuration mode. So config if means configure interface configuration mode, and the identification is router config if and hash. Now, what are the tasks you can do in your interface configuration mode? You can assign the IP address to the interface. You can bring the interface down or up, because all the interfaces of your router are by default in the down state. So you will have to manually bring that router or the interface up. Okay, this is clear. How you can assign IP address to the router? See, to assign the IP address to the router, you have to go to the interface, and then you have to write the command IP address. Okay, and then you have to give the IP. Let's say I want to give the IP 192.168.10.1. With the IP, we always write a subnet mask. So I want to use the default subnet mask. What is the default subnet mask? 255.255.255.0. That's it. It is done. Now, interface is by default in the down state. Interface is by default in the shutdown state. So to bring it up, no shutdown. To bring the interface up, you have to say no shutdown. This is how you assign IP to your router interface. And you can see, as soon as I say no shutdown, interface gigabit Ethernet 0/0 change state to up. My interface is up. This is clear. So these are the commands with the help of which you can assign IP address to your router interface. This is clear. So in the user execution mode, you can run limited number of commands. Your privilege mode you'll use to monitor and troubleshoot. And you can do some basic configuration, like you can change the date and time of your router. Okay. And entire configuration is done in the global configuration mode. Interface configuration mode, you attach the IP address and you make the interface either down or up. By default, all your interfaces will be down. This is clear. Now we'll see about these modes. So your first mode, it is the user execution mode. Okay. So as soon as the interface up message appears, because whenever the router turns on, the interface up or down message will be appearing. And if we press enter, we'll be seeing this particular prompt, router and greater than symbol. Okay, this is called user execution mode. This mode is limited to some monitoring commands only, very limited number of commands you can execute. Then second mode, we have the privilege mode. So as soon as we type the enable command in the user execution mode, we enter into the privilege mode. In the privilege mode, we can view and change the configuration of the router. Change the configuration in the sense very limited change, like changing the date and time. Different commands like show running configuration, show IP interface brief can run on this mode, which are used for troubleshooting purpose. See, I'll be discussing the commands in the privilege mode and the global configuration mode. And also I'll be sharing a notepad file of the basic commands. Okay. So these are some commands like show running configuration. So with the name or with reading the command, you can see that we are going to see the running configuration of the router. Show IP interface brief means on interfaces, what is the IP configuration we can see with the help of show IP interface brief command. Okay. So these are the commands you can execute in your privilege mode. Clear? Simply view and change the configuration, or troubleshooting purpose, you are going to use privilege mode. The next mode we have is global configuration mode. So as soon as you type configure terminal command in the privilege mode, you will enter the global configuration mode. Okay. And whatever commands you enter in the global configuration mode, they are called as global command. Why? Because they are going to affect the running configuration of the router. Okay. Whatever changes we are doing in the router, whatever commands we are executing, they are affecting directly your RAM, because that is getting configured. And whatever configuration is running in your router, that is stored in the RAM. In this mode, different configuration like making local database on router by providing username and password. You can create username and password on the router. Can set enable and secret password. You can set passwords on the router. So all those commands you can run in the global configuration mode. Okay. Next, we have interface configuration mode. Interface configuration mode means we are mainly focusing on a particular interface. So on an interface, either we can set the IP address, we can bring the interface down or up. So in this mode, only configuration of interfaces are done. Assigning IP address onto an interface, bringing up the interface are the common tasks done in this mode. This is clear?
You can begin to say yes.
Yeah, that is needed only for the basic configuration. But if you want to do the manual configuration, you have to set it manually. Okay, like IP addresses and all these information, you can do like that also. But that is going to ask you again a lot of questions. There will be some questions you don't want to configure, like basic configuration. Let's say we would just want to assign an IP address to an interface and make a small network for our connectivity purpose. So if we go with this initial system configuration dialog, it is going to ask you a lot of questions. And a lot of configuration will be useless. Yes, because you do what configuration you want. Okay. Then we have this Roman mode. This Roman mode is very important. You can say like your BIOS. Okay. Let's say Windows corrupt. Windows got corrupt. So what you're going to do with the help of BIOS, you can use a pen drive and install the Windows again. Let's say you forgot the Windows password. Again, with the help of your BIOS, you can boot your Windows through an external bootable media and you can crack the password. Same way, if you want to crack the password or for your router, if you want to restore the iOS, if you want to restore the, you can say configurations. Okay, all those tasks you can do in the Roman mode. So we enter this mode when we interrupt the boot process. So either you manually interrupt the boot process, or if the iOS is not found, it is automatically interrupted. Generally, we enter this mode while password recovery process or backing up of iOS on devices like TFTP server. Clear? Then it is like BIOS mode of your PC. Same thing, because it is the Roman mode. Clear? Any doubts? Then these are the examples where you can see user execution mode, you can identify with the help of router greater than symbol. Privilege mode, you can identify with the help of router hash. Global configuration mode with the help of router config hash. Interface configuration mode, router config if hash. So any doubt in today's part? No? Clear to everyone? Online people, any doubt?
No.
Okay then. Yes, sir. Yes, yes. Sorry. Can you speak louder? I cannot hear.
I want to say more performing packet reader.
Yes. We'll be showing, I will be showing you practical. Okay.
When is the practical start?
Maybe after tomorrow.
After 4?
Yes. And by that, by Friday or Thursday or Friday, we'll be going to the lab also. Okay. We'll be accessing the real devices and we'll be doing some configurations. Okay. Because right now we haven't done any configuration part yet. So if we go right now, it is of no use. So Thursday or Friday, we'll be going. Clear? So if there are students in online who want to join the lab session, so they can be physically present here on Thursday and Friday. So Thursday and Friday, we'll be going to the lab. Clear? So this is all for today. I'm done for the day. Thank you guys. Have a great day. Bye.